Have you ever stopped to ponder what exactly is time? This seemingly simple question opens up a vast world of complexity and intrigue. Time, a fundamental part of our lives, is as mysterious as it is omnipresent. We live it, we measure it, we even try to manage it. But what truly is time? Throughout history, humans have conceptualized time in a myriad of ways. Ancient civilizations marked time using the positioning of celestial bodies, creating the first sundials. This concept of time was purely observational, relying on the apparent movement of the sun across the sky. As our understanding of the world evolved, so did our perception of time. With the advent of mechanical clocks in the 14th century, time became quantifiable, segmented into hours, minutes, and seconds. This was a revolution in human consciousness, transforming time from a natural phenomenon into a man-made construct. But the story doesn't end there. The 20th century brought about a new perspective on time, thanks to the groundbreaking work of Albert Einstein. His theory of relativity proposed that time is not a simple, flowing entity. It's woven together with space, creating a four-dimensional fabric known as spacetime. This was a radical departure from previous understandings, suggesting that time could be warped and distorted by gravity. In the realm of particle physics, the enigma of time takes on an even more puzzling form. Quantum mechanics, the theory that describes the behavior of particles at the smallest scales, challenges traditional notions of time. It presents a probabilistic, discrete, and relational view of time, further complicating our understanding of this elusive concept. Today, our most accurate timekeeping devices, atomic clocks, rely on the principles of quantum mechanics. They track time based on the vibration of atoms, achieving a precision that would lose only 1 second every 100 million years. Yet, despite all these advancements, time remains a profound mystery. It's both tangible and intangible, concrete and abstract, a constant presence in our lives, yet an elusive entity that defies full comprehension. Time, as we know it, is a complex concept that continues to baffle scientists. This enigma of time, a concept so integral to our existence, yet so far from our full understanding, continues to fuel the pursuit of knowledge in the fascinating world of science. Did you know that the quantum world challenges our traditional understanding of time? When we delve into the realm of quantum theory, our conventional concepts of time start to unravel. Theoretical physicist Carlo Rovelli provides a unique perspective on this matter. He sees quantum physics as probabilistic, discrete, and relational. But what does this mean? Let's break it down. Probabilistic refers to the idea that at the quantum level, things aren't set in stone. Instead, they exist in a cloud of potentialities, and their actual state only becomes clear when they are observed. This is where the famous Schrodinger's cat thought experiment comes into play, suggesting that a cat in a box could be both alive and dead at the same time until observed. The idea of quantum physics being discrete means that it's composed of distinct, individual packets. Think of it like a string of pearls, where each pearl represents a quantum event. The string doesn't flow smoothly, it jumps from pearl to pearl. And then we have the concept of relational quantum physics. This simply means that the properties of quantum particles are not absolute. They depend on their relationship with other particles. A particle state is not just about it alone, but how it interacts with the rest of the universe. Now, how does this all tie in with time? Well, in the quantum realm, observation is about interaction, not human consciousness. When a quantum system interacts with another, the state of the first is affected. This interaction can be seen as a kind of measurement or observation. It's not about a conscious observer looking at a clock, but rather about how different systems experience each other in their own unique quantum way. This quantum perspective shakes up our understanding of time. We're used to viewing time as a constant flowing river, but in the quantum world, it's more like a sea of interactions happening in a probabilistic, discrete, and relational manner. In the quantum realm, time is not as straightforward as tick-tock. What if time is more about perception than reality? Picture this. You're waiting for a bus, and it feels like an eternity. But when you're engrossed in a good book, hours pass by like minutes. This difference in perception isn't just about boredom and interest. It's an example of how time, as we understand it, can be subjective. Now let's take this a step further. Some cultures perceive time as a linear progression, a straight line from the past to the future. Others see it as cyclical, a loop of recurring events and seasons. These differing views on time can influence everything from work habits to philosophy. But what if time isn't real at all? There are theories in the world of physics that propose just that. For instance, Julian Barbour, a British physicist, suggests that time is an illusion. According to him, the universe is a collection of nows, and what we perceive as time is merely a mental construct that helps us make sense of those nows. Similarly, Carlo Rovelli, in his book Helgoland, explores quantum concepts that challenge traditional notions of time and reality. He explains that observation in quantum mechanics is about interaction, not human consciousness. This means that time might not be a fundamental aspect of reality, but rather a product of our interactions with the world. Even in the realm of digital technology, time takes on a new dimension. Take the creation of Bitcoin by the elusive Satoshi Nakamoto. The transactions in the blockchain are time-stamped, creating a kind of digital time that exists independently of our human perception. So, what does all this mean? Well, it's possible that time, as we understand it, is not a universal truth. It might be more akin to a language, a way for us to navigate and make sense of our world. Time might be less about reality and more about how we perceive and interact with the world around us. With all these theories, what can we really say about time? We've journeyed through the enigma of time, delved into quantum theory's perspective, and explored the relationship between time and reality. Yet here we stand, at the threshold of understanding, looking into the abyss of one of the greatest mysteries of science, time. We live in an era of unprecedented technological advancements. We've mastered the art of splitting atoms, we've sent probes beyond our solar system, and we've even begun to unlock the secrets of the human genome. Yet when it comes to time, we're still scratching our heads, trying to piece together a puzzle with an infinite number of pieces. Theoretical physicists like Carlo Rovelli continue to challenge traditional notions of time, suggesting that it is probabilistic, discrete, and relational. Yet, these notions are far from universally accepted. There are ongoing debates and discussions, with scientists from different fields bringing their own perspectives to the table. Some argue that time is an illusion, a human construct designed to make sense of our existence. Others believe that time is a fundamental aspect of reality, intimately linked with the fabric of the universe. Meanwhile, research continues. Scientists are pushing the boundaries of our understanding, delving deeper into the quantum realm, and exploring the farthest reaches of the cosmos. They're developing new theories, conducting experiments, and gathering data in their quest to understand the nature of time. Yet, despite all this effort, time remains elusive. It continues to tick away, second by second, indifferent to our attempts to understand it. It's a testament to the complexity of the universe and the limitations of human understanding. In the grand scheme of things, we're just starting our journey of discovery. There's so much we don't know, so many questions left unanswered. But that's the beauty of science. It's a never-ending quest for knowledge, driven by our innate curiosity and desire to understand the world around us. As we continue to explore the depths of the universe and the intricacies of our minds, we may one day unravel the true nature of time. Time, as elusive as it is essential, continues to be a subject of fascination and intrigue. We've embarked on a journey, exploring the enigma of time, from its fundamental nature to the profound implications of quantum theory. We've delved into the profound correlation between time and our perception of reality and the mysteries that continue to baffle us. Through this exploration, we hope to have sparked curiosity, a desire to understand the very fabric of our existence. Our understanding of time is always evolving, shaped by the brilliant minds of scientists like Carlo Rovelli and Werner Heisenberg, who dared to question the status quo. We've learned that time is more than just ticks on a clock. It's a complex, multi-dimensional concept that challenges our traditional notions of reality. Yet, there's so much more to learn, so much more to understand. So, we encourage you to ponder, to question, to explore your own perception of time. How does it influence your life? How does it shape your reality? As Albert Einstein once said, time is what prevents everything from happening at once. So keep exploring, keep questioning, and remember, time is always on your side.